Okay, welcome to ASVAB Math Knowledge Lesson 1. This is primarily aimed at people who are maybe retaking the ASVAB after a few years and don't really remember everything that they learned in high school. Maybe you're retaking it to get a better score so you can do some kind of program or something like that. Whatever it is, it's been a while since you've done math, here we go. So this is Lesson 1. We're going to start off with some stuff that's pretty, I would say pretty basic. But essential. So if you remember, that's great. If you don't, just stick around and learn once again. So the first thing we're going to talk about here is the order of operations. Now, the order of operations is really important. It's the basic building block of how we do math, and it literally means the order in which we apply math. And the order of operations always goes like this. PEMDAS. PEMDAS, PEMDAS, PEMDAS. That is a D. My penmanship is not that good. But just repeat this until you get sick of it. You should be able to recall this immediately and apply it at all times. This is how your calculator does math. This is how everybody does math, and it's really, really important because if you do this in the wrong order, you can get a totally different answer, which I'll show you some examples of. But PEMDAS is an acronym. PEMDAS stands for parentheses, exponent, multiplication, division, addition, and subtraction. Now, parentheses are always step 1. Exponents are always step 2. Multiplication and division together are step 3. Addition and subtraction together are step 4. Okay, so now I'll go a little bit more into each one of these steps because there's some important things to note throughout. So if we start out with parentheses. Parentheses, it's really, really simple. If you ever see a set of parentheses around some numbers, that's the first thing you're going to take care of is what's inside those parentheses. So if we just have 7 plus 4 times 3, and we just evaluate this, no parentheses, anything like that, 7 plus 4 is 11 times 3. 11 times 3 is 33. However, if we have 7 plus quantity 4 times 3, we're going to evaluate what's in the parentheses first. So 4 times 3 is 12. 7 plus 12 equals 19. Easy. If we have two sets of parentheses, say we have 4 plus 6 in parentheses times 3 and a bigger set of parentheses, or brackets, either way, plus 2. We're going to evaluate the inside parentheses first. So 4 plus 6 is 10. This becomes 10 times 3 plus 2. 10 times 3 is 30, plus 2 is 32. And then if you ever see a number and there's parentheses and then another number, that's the same as just saying 2 times 3 or 2 times 3 in this way. These are just different notations of saying 2 times 3. It all equals 6. It's all the same. Okay, that's pretty much all there is to say about parentheses. Let's move on to exponents. Exponents are a little bit more complicated. There's some pretty important rules surrounding exponents. Exponent. Now what an exponent is, I keep clicking my pen by accident. What an exponent is just a number, so let's take a variable a to the power of another number. So this would be a to the m. And all that means is a times itself m number of times. So if we have 2 to the third power, or 2 cubed, that's the same as saying 2 times 2 times 2. That equals 8. 2 to the third power, 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8. Easy. That's basic what an exponent is. And there's some rules to remember here. Give me 1 second. Okay, like I said, there's some rules to remember. There are some properties of exponents. I know my penmanship is really bad. By the way, if you ever see this, I know this looks like a Z. That is always a 2. If you ever see me write a Z, I'm going to have that little Dragon Ball Z line in there so you know. Okay, so properties of exponents. The first one to remember is that a to the first just equals a. If you think about it, it makes sense because this is a times itself one time. So it's just a times itself, a. A to the 0 power equals 1. Does not equal 0. There's reasons for this. It gets a little, that's a little outside the scope of this video to talk about why that is. But all you need to know is that a to the 0 equals 1. These are all really important things to remember. These are probably more than likely going to be on the test. Okay, so another property of exponents that I want to talk about is a to the m times a to the n is the same thing as a to the m plus n. And this kind of makes sense if you work it out here. So let's take 2 squared times 2 to the third, right? If we use our property here, that's the same as saying 2 to the second plus 3. And if we evaluate 2 plus 3 up here, that's 2 to the fifth. Now what's 2 to the fifth in a calculator? 2 to the fifth in a calculator is, give me just a second. Fucking damn it. Okay, you probably saw my OBS window there. I am not a editor. I don't know how to edit videos, and I'm not restarting the recording. I probably should have said this at the beginning of the video, but my credentials, I am an engineer. I work as a professional engineer, not a professionally licensed engineer yet, but I did take the ASVAB when I was in high school. I got a 97 out of 99 G on the overall score, so I definitely know what I'm talking about here. Yeah, anyway, so 2 to the fifth is 32. Just type that into a calculator, and you'll see that 2 to the fifth equals 32. Oh, and also, if you ever see notation that looks like this, 2 caret, this is a caret, K-A-R-A-T, I believe. It's the same as saying 2 to the fifth. Okay, so, but how do we prove that? Well, if we take this and we go 2 times 2, we put that in parentheses, times 2 to the third, which is 2 times 2 times 2. When we just evaluate this, well, 2 times 2 is 4. 2 times 2 times 2 is 8. 4 times 8, oh yeah, look at that, it's 32. Makes sense. I'm going to erase that. If you want to keep that example, just go ahead and write it down in your notes. I'm just going to erase that to save space. Okay, on to the next rule for exponents. What do we got here? Oh, we got a to the m divided by a to the n equals a to the m minus n. And it's really important to remember here that the m comes first. This first one, this one that's on the numerator, you may remember numerator and denominator. On a fraction, the numerator is on top, the denominator is on the bottom. Just remember d for down, d for denominator. Let's prove that as well. Let's go 3 squared divided by 3 to the third. That's a 3. My penmanship's really bad, I'm sorry. So if we just evaluate this, how it is, we have 3 times 3 over 3 times 3 times 3. Okay. So that equals 9 over 27, which if we reduce this fraction down, which we'll talk about that later. If you don't remember reducing fractions, don't worry about it right now. Just take my word for it. This is 1 over 3. And if we do 3 to the 2 minus 3, like with our identity here, we utilize our identity, that equals 3 to the negative 1. And this demonstrates our other rule. Another rule for exponents is that a to the negative m is the same thing as 1 over a to the m. That's what's called the reciprocal. The reciprocal of a number is always just you flip the numerator and the denominator. And the reason that that's a 1 is because any number a is technically the same as saying a over 1. This is really useful for if you're ever needing to multiply by a fraction or anything like that. Just remember that if you just have a number, it's the same thing as because a divided by 1 is just a. Okay. So yeah, so this makes sense. 3 to the negative 1, if we use our other identity here, is the same as 1 over 3 to the 1, which if we look at this guy, see how it all ties together, is just 1/3. So there we've proven our division rule. Okay. Now let's move on to our next one. We've got 8 of these. Okay, so if we've got a to the m to the n quantity, that is the same as saying a to the m times n, or a to the mn. So what that looks like here is, let's go again, 3 squared to the third power, so cubed, is the same as saying 3 times 3, right? That's what's inside these parentheses, 3 times. This times itself 3 times. Okay, makes sense. 3 times 3, 3 times 3, times 3 times 3. And since this is all multiplication, it's just all one thing. So it's just 3 times 3 times 3 times 3 times 3 times 3. Makes sense. So that's 9 times 9 times 9. 81 times 9 is what? 81 times 9 is 729. And if we check with our calculator again using our identity, that should equal 3 to the 2 times 3, same as 3 to the 6th power, which if we check that in our calculator, 3 to the 6th power. Look at that, 729. I know you can't see my calculator, but if you want to do it for yourself, go right ahead. I guarantee you'll get the same answer. And if you didn't, you probably messed up PEMDAS somewhere. Okay. Now, moving on. Okay, AB to the M power equals A to the M times B to the M. Let's do an example of that. If we've got 3 times 2 squared. Well, if we look in here, well, 3 times 2 is 6. 6 squared. 6 times 6 is 36. Okay, cool. So now if we use our identity, if we go 3 squared times 2 squared, well, 3 squared is 9. 2 squared is 4. 9 times 4 is 36. It all makes sense. These identities are basically just rules to make things faster. Sometimes it's easier to evaluate something like this. Sometimes it's easier to evaluate something like this. And on the test, time is your enemy. It is a time test. The less amount of time you can spend solving these problems, the more time you have for the more complicated ones, the ones that maybe you need to work out a little bit more on. Okay. So now our final rule for exponents is A over B to the M equals A to the M over B to the M. And that once again makes sense. Let's go 3 squared over 2 squared. This is the same exponent, remember? Well, that's the same as saying 3 times 3 over 2 times 2 equals 9 over 4. Okay, cool. Which, if we do this the other way, that's using the identity. If we don't use the identity, it would be 3 halves squared would equal 1.5 squared. If we put that into a calculator, 1.5 squared, that equals 2.25. And if we do 9 over 4, that also equals 2.25. And this illustrates something that is really important as well. It's going to make you faster at math without a calculator. It is 90% of the time easier to work with fractions than it is to work with decimals. Like 1.5 times 1.5, you know, maybe you know that off the top of your head. I don't. You know, but I can do 3 halves times 3 halves. That's easy. And if you don't remember how to multiply and divide by fractions, we'll talk about that probably in another video. We're just going to be focusing on rules of exponents and order of operations for this one. But multiplying and dividing by fractions and doing math with fractions, that's all really, really important for the exam as well. Okay, so those were our rules for exponents. Excuse me, sorry. Take some time, look at these. Make sure you have these. You don't necessarily have to have these all memorized, but you should know them because it'll make your life easier. Okay, so next in our order of operations, we have multiplication and division. We're not going to take a whole lot of time to go through, basic multiplication and division. If you don't remember your times tables, that's something that you should drill. But the important thing to know about multiplication and division is that it's all one step. So whatever shows up first in an equation is just what you do first. So for this one, since we have 7 times 3, we're just going to do that right now. 21 plus, we have 4 divided by 2, so we do that. These technically happen at the same time. So this would be 21 plus 2. You'll notice even without the parentheses, we still are doing this first before we do the addition. That's 23. Those happen at the exact same time. And then step 4, addition and subtraction. We're also not going to go over addition and subtraction. Those also happen at the same time, just left to right. So if you have 7 plus 4 minus 3 minus 2, we're just going to evaluate this left to right, just like how we read. So that's going to be 7 plus 4 is 11, minus 3 minus 2. 11 minus 3 is 8. Took me a second. Minus 2. And 8 minus 2 is 6. So that's PEMDAS. Just get this into your head as much as you possibly can, because this is really, really important to remember. They will try to trick you with this kind of stuff on the exam. So just remember PEMDAS and you'll be okay. Remember PEMDAS, remember these properties of exponents. They're all really important basic math knowledge to know for the exam.